Welcome to section 3.6, Electron Energy Levels. In order to talk about electron energy levels, the first thing we have to do is we have to look at something called the electromagnetic spectrum. The electromagnetic spectrum is the arrangement of wavelengths, in the electromagnetic radiation. The visible light range, and you can see this is a very large range and it's increasing as energy as you go. But the visible light range is this very, very small area right here. This is the different lights we can see, and they range from length in 700 to 400 nanometers. So where this shows up is if you have a light from an element that's been heated up, like this is something called a flame test, where you can take the metal and you heat it, and when you heat it, it gives off a certain color, and this is characteristic of particular metals. They give off a certain color, and so that light from the color, if you send that through a prism, that prism will then separate the visible light spectrum into bands, and these are called spectra. One is called a spectrum, and there's different characteristics depending on which element you're heating up. This is the spectrum for strontium. This is the spectrum for barium. So you can see they have different lights that make up that spectrum. In these electron levels, there's different amounts of energy, and the energy levels that these electrons are in are assigned numbers in 1, 2, 3, 4, 5, etc. So as you increase in number of N, the energy gets higher. And so they're showing you down here you're increasing in energy, so that this is a lower energy than this. And so it's like rungs of the ladder, because you have the lowest energy at the bottom and you have the highest energy at the top of the ladder. So energy levels have a maximum number of electrons, and the way you know that number is it's 2 times the energy level squared. So if you have energy level 1, you have 2 times 1 squared. 1 squared is 1, so 2 times 1 is 2. So the maximum number of electrons you can have in the first energy level is 2. In the second, n equals 2, it's 2 squared, which is 4, times 2. So the maximum you can have is 8. With 3, you can have 18, and so on. So that's just a way of calculating the maximum number of electrons that you can have in an energy level. So electrons will move from a low energy to a high energy by absorbing energy. So if you hit it with some type of energy to excite it, they call it, it will actually jump up to a higher energy level. It won't stay because it absorbs the energy to get up there, but then it's going to give off that energy in the form of light as it falls back down to its normal energy level. That energy that you emit as it falls back down is equal to the amount of energy it absorbed. So whatever energy it absorbs that knocks it up to a higher energy level, when it falls back down, it gives that same amount of energy off. So what they're showing you here is that you absorb this certain amount of energy, and it's this tall, and then so the electron moves up to the higher energy level. When it gets up here, though, it's not going to stay. It's going to fall back down, and it's going to emit the same amount of energy. The higher the amount of energy you put in, the higher the energy is going to be emitted. And so this is showing you that it's a shorter wavelength energy because it's a higher energy. So this N number is really the period numbers, these horizontal rows. So H or hydrogen and helium are both in the first energy level, N equals 1. So the maximum number they can have in their first energy level is 2 electrons. Hydrogen doesn't have 2 though. It's not full, so it only has 1. Helium though is full, so its 2 electrons are both in that first energy level. In period 2, as you look at the periodic table, you'll see lithium, barium, boron, carbon. So as you go across that periodic table, you're going to have 2 that are already filled, and then you're going to have 1 for lithium, 2 as you go across, 3 for boron, 4 for carbon. See how that works? So basically you're filling in the number of electrons until you get up to 8 when you get to the end of that row, that period, and you see neon. Period 3, same pattern. You're going to get 2, 8, and then you start filling the third energy level until you get up to 8. So you can actually count across. I hope you're looking at your periodic table as I'm talking in your book or whatever, because you can follow it along as you see that it's filling, and it just adds as you go across that periodic table. And then finally, period 4, we're only going to look at potassium and calcium for purposes of this class, and you can fill those as you get into the fourth energy level. So the number of electrons that you can have in total in the first energy level is 2. Remember, the way we can do this is 2n squared, okay? The second is 8, third is 18, then you've got 32, fifth is 32, and there's reasons why. That's why we really stop looking here for our purposes, otherwise it gets kind of complicated. But what you do is you write the electron configuration or the electron arrangement down here by saying, okay, in oxygen I've got 2 in the first level and 6 in the second level because I have a total of 8 electrons. So you have to fill that first one, then you can fill the second one. How many could you have in this? You could have 8, right? But you only have 6, so it's not full. Phosphorus, you fill 2, you fill the second one with 8, and then you have 5 in that outer energy level. Calcium, look at the periodic table as you go. 2, 8, 8, and then 2 in that outer level. So let's see if you can write the electron configurations of these. You look at how many electrons do they have. How do you find that out? Well, you look at the atomic number, right? And you know that you can have 2 and then 8 and then 8 and then fill the fourth. Okay? So put them on pause. Let's see what you do. Right. So carbon is atomic number 6, 2, and then 4. Silicon is atomic number 14. You have 2, then 8, then the third level you only have 4. Oxygen is number 8, 2, and 6, and nitrogen is 7. So you have 2 and 5. So none of these are filled in these outer shells, right? They still have room for more electrons. That gets important later when we start looking at chemical bonding. So that's the end of electron energy levels. That wasn't so bad, was it? The only thing we saw math-wise was 2n squared, where n is what? The period number or the energy level. Same thing. Hopefully you will join me for 3.7. I think that's the last section of Chapter 3.